Hello there, and welcome to the Dreamy Ocean Channel. As you settle into this quiet moment, let your awareness gently soften. Unclench your jaw, release the tension from your shoulders, and feel your breath deepen, slowing into a peaceful rhythm. How can something so utterly still, so deceptively ordinary, hold within its very being a power capable of bringing the mightiest to their knees? In the sun-dappled shallows of our vast oceans, there lies a creature that has mastered the art of illusion, a living rock whose stillness belies a potent, ancient secret. It waits almost imperceptible, a silent guardian of the reef, yet possessing a defense so profound it has earned the chilling title of the world's most venomous fish. Let us now, with minds calm and open, slowly descend into its hidden world. Introducing the Stonefish Enigma. The journey begins in waters warmed by the equatorial sun, where the vast blue expanse of the Indo-Pacific cradles an astonishing array of life. Here, beneath the gentle sway of the surface, where sunlight filters down in shimmering columns, illuminating coral gardens of impossible beauty, there exists a creature that defies easy perception. It is not a fish that darts with silver flashes, nor one that glides with elegant fins through the liquid sapphire. Instead, it is a being of profound stillness, a master of unobtrusive existence blending so perfectly with its surroundings that to behold, it is often to miss it entirely. This is the stonefish, a name whispered with a mixture of awe and caution among those who know the secrets of the reef. Its very essence is rooted in deception, a living sculpture crafted by evolution to mimic the inert, the unmoving, the utterly harmless. Imagine a patch of the ocean floor, perhaps a scatter of volcanic rock, encrusted with the subtle greens and browns of algae, punctuated by the occasional fragment of dead coral, bleached and porous. Now within that seemingly random collection of detritus, allow your gaze to linger, to search for the anomaly, the pattern that isn't quite right. Yet the stonefish resists such easy identification. Its skin, a marvel of biological artistry, is not smooth or scaled in the conventional sense, but rather a rugged, uneven landscape of bumps, ridges, and fleshy protuberances. These are not merely decorative, they are integral to its disguise, mimicking the irregular surfaces of worn stone, the rough texture of eroded coral, or even the lumpy contours of a sponge. The coloration of this silent sentinel is equally a testament to its stealth. It is rarely vibrant, never flamboyant. Instead, its palette is drawn from the very substrate it inhabits. Muted greys, dull browns, mottled creams, and the occasional hint of olive green or rusty red, all blended in a chaotic yet exquisitely harmonious pattern. These hues are not fixed. They possess a remarkable ability to shift and adapt, allowing the stonefish to synchronize its appearance with the ambient tones of its specific resting place. A stonefish nestled amongst dark basalt might deepen its own shadows, while one resting on pale sand near a bleached coral head might lighten its complexion, dissolving its outline into the diffuse light. This adaptive chromatism is a slow, deliberate process, not a sudden flash, but a gradual absorption of its environment's visual essence, making it a true chameleon of the seabed. Its form, too, contributes to this masterful illusion. The body is broad and flattened, almost compressed, allowing it to hug the contours of the seafloor without casting a discernible shadow that might betray its presence. Its fins, rather than being delicate instruments of propulsion, are thick, fleshy, and often fringed with irregular edges that further break up its outline, preventing the eye from perceiving a continuous fish-like shape. The pectoral fins in particular are broad and fan-like, often spread wide to press the body firmly against the substrate, creating the illusion of a sessile organism rooted to its spot. The dorsal fin, perhaps its most distinctive feature, is not a graceful sail, but a series of rigid, bony spines, each one stout and menacing. Yet when folded flat against its back, they merge seamlessly into the rugged topography of its skin, becoming just another irregularity on a seemingly inert surface. This profound stillness is not a sign of lethargy, but rather a highly effective hunting strategy and a primary defense mechanism. The stonefish does not chase its prey. It becomes the environment that its prey unwittingly approaches. Small fish crustaceans and other unsuspecting marine life drift or crawl by perceiving only a harmless rock, an unremarkable part of the reef's furniture. They forage, they rest, they pass within striking distance, utterly oblivious to the living trap that lies dormant just inches away. And then, with an almost imperceptible flick, a sudden explosive gulp, the stonefish reveals its true nature, for a fleeting moment swallowing its meal whole before resuming its stony vigil, becoming one with the seabed once more. The enigma of the stonefish extends beyond its camouflage. It is the paradox of a creature so passive in its appearance, yet so profoundly potent in its defense. For within those seemingly innocuous dorsal spines, carefully concealed beneath layers of skin and mucus, lies a complex and exceptionally potent venom. This is the secret that elevates the stonefish from a mere master of disguise to a legend of the deep, a reputation earned through countless, often painful encounters with unwitting humans. Its venom is a cocktail of neurotoxins, cytotoxins, and cardiotoxins, a sophisticated biological weapon designed not for predation, but purely for protection. When threatened, when inadvertently stepped upon by a wader or brushed against by a curious hand, the stonefish does not flee. Instead, it erects those formidable dorsal spines, each one a hypodermic needle ready to deliver its searing payload. The scientific world recognizes this family of fish as Synansidae, a group within the order Scorpaeniformes, which includes other spiny, often venomous bottom dwellers like scorpionfish. The genus Synansia specifically houses the true stonefishes with species like Synansia horrida and Synansia verrucosa. Being among the most well-known and widely distributed, the name itself, Synansia, hints at this profound connection to its environment, perhaps deriving from Greek roots, suggesting a coming together or union, a fitting descriptor for a creature so utterly united with its surroundings. These ancient lineages suggest a long, successful evolutionary journey, millions of years spent perfecting the art of stillness and the science of potent defense. Geographically, the stonefish predominantly inhabits the warm, shallow waters of the Indo-Pacific region, a vast expanse stretching from the Red Sea and the east coast of Africa across the Indian Ocean through the archipelagos of Southeast Asia and extending eastward into the Pacific Ocean, reaching as far as French Polynesia and the southern coasts of Japan. Within this immense territory, it favors specific microhabitats, coral reefs, rocky outcrops, tidal pools, and even areas of sandy or muddy bottom where it can partially bury itself. It thrives in the intertidal zone where the ebb and flow of tides expose and submerges its resting places, making it a particular hazard for barefoot waders or snorkelers exploring the shallows. Its presence is a constant, though largely unseen factor in the ecological dynamics of these vibrant underwater worlds. For millennia, coastal communities and indigenous peoples living along these shores have harbored a deep respect, often bordering on fear, for this unassuming creature. Tales of its potent sting have been passed down through generations, cautionary warnings woven into the fabric of daily life near the ocean. Fishermen learn to navigate the reefs, with care divers are taught to observe before touching, and children are educated about the dangers lurking beneath the seemingly benign seabed. This creature, which spends most of its life in motionless vigilance, has carved out a formidable reputation purely through the devastating effectiveness of its defensive mechanism. It is a testament to nature's ingenuity, a reminder that the most profound power often resides in the most unexpected and outwardly modest forms. As we begin to peel back the layers of this fascinating enigma, we are invited to consider the intricate balance of life and death in the marine environment. The stonefish is not malicious. It is simply a creature perfectly adapted to its niche, a living embodiment of the principle of survival. Its existence underscores the hidden wonders and potential hazards that lie just beneath the surface of our awareness, inviting us to look closer, to observe with greater patience, and to understand the silent, ancient forces that shape the wild places of our planet. Its presence is a gentle yet firm reminder of the profound respect due to all forms of life, especially those that choose to remain in the shadows, waiting. This introduction to the Stonefish Enigma sets the stage for a deeper exploration, allowing us to slowly unfurl the scientific marvels and the hidden dangers encapsulated within this singular rock-like being. We move now with a quiet curiosity towards understanding the precise mechanisms of its camouflage, the intricate details of its habitat, and the potent biochemistry that makes its defense so uniquely formidable. The ocean continues its soft, rhythmic breathing around us, a lullaby accompanying our gentle descent into knowledge. The art of disappearing. The ocean's soft, ceaseless currents continue their gentle embrace, carrying us deeper into the silent artistry of the stonefish. We turn our attention now to the very heart of its mystery, the profound stillness that defines its existence, the exquisite, painstaking craft of its disappearance. For the stonefish does not merely hide, it becomes. Its surroundings dissolving its very form into the intricate mosaic of the reef floor, a master illusionist performing an eternal, unblinking act of vanishing. Consider the surface of its skin not as a mere covering, but as a living canvas, a biological tapestry woven with astonishing detail. Unlike the sleek, iridescent scales of many fish, the stonefish possesses a dermal landscape that is rugged, gnarled, and profoundly irregular. Imagine a miniature topography of ridges and furrows of fleshy protuberances that resemble the knobbly textures of encrusting sponges or the calcified growths of dead coral. These are not random formations. They are meticulously evolved structures, dermal papillae and filamentous appendages that break up the creature's outline with such effectiveness that the eye struggles to discern a continuous form. When observing a patch of reef, our brains are wired to identify patterns to seek out the familiar shapes of living organisms. The stonefish cleverly disrupts this process, presenting a visual chaos that mirrors the natural clutter of its habitat, forcing the observer to perceive only scattered detritus, not a unified living being. Its coloration, too, is a symphony of muted tones drawn directly from the palette of its environment. We are not speaking of vibrant blues or striking yellows, but rather the subtle, earthy hues of the seabed. Imagine a blend of dull greys that echo volcanic rock, mottled browns reminiscent of decaying algae, creamy whites that mimic bleached coral fragments, and occasional flecks of olive green or rusty red like mineral deposits or patches of benthic growth. These colors are not static. Within the stonefish's skin lie specialized pigment cells, known as chromatophores. These remarkable cells, particularly the melanophores containing dark melanin, the xanthophores with yellow pigments, and the erythrophores with red pigments, allow the stonefish to slowly adjust its coloration. It is not the rapid, dramatic color change of a chameleon or an octopus, but a gradual, deliberate process, a subtle deepening or lightening of its overall tone to precisely match the ambient light and the specific substrate upon which it rests. A stonefish settled upon a dark basalt outcrop will deepen its shadows, absorbing the surrounding gloom, while one lying on pale sand near a sun-drenched coral head will lighten its complexion, diffusing its edges into the bright reflective surface. This slow, almost imperceptible transformation allows it to truly melt into its chosen resting spot, becoming an indistinguishable part of the very ground beneath it. The very architecture of its body further enhances this profound camouflage. Its form is broad and flattened, designed to hug the contours of the seafloor with minimal elevation. This low profile reduces the shadow it casts a critical factor in remaining undetected, as shadows can betray the presence of an object even if its form is obscured. Its pectoral fins, rather than being used for active propulsion, are often spread wide and pressed firmly against the substrate, expanding its apparent base and further obscuring its true outline. The dorsal fin, a formidable array of stout venomous spines when relaxed and folded flat, integrates seamlessly into the rugged, lumpy texture of its back, becoming just another irregularity in its stony facade. Even the eyes, often a telltale sign of life, are small and often obscured by fleshy growths blending into the surrounding dermal chaos, rarely reflecting light in a way that would give away its position. This visual mastery is complemented by an unwavering commitment to stillness, a behavioral camouflage that is perhaps its most potent weapon. The stonefish is an ambush predator, a creature of profound patience. It can remain motionless for hours, sometimes even days, in the same spot waiting. This extreme immobility is a crucial element of its disappearance act. Most marine predators, and indeed many prey animals, rely heavily on movement as a primary cue for detecting other organisms. A darting fin, a shifting shadow, a subtle ripple in the water. These are the signals that betray presence. By remaining utterly inert, the stonefish effectively removes itself from the sensory radar of most creatures. It becomes, to all intents and purposes, an inanimate object, a part of the permanent landscape. When it does move, it is typically a slow, deliberate crawl, a shuffling motion across the seabed, or a sudden, explosive lunge to capture unsuspecting prey. But these movements are fleeting. For the vast majority of its existence, the stonefish is a living statue, a silent sentinel of the reef. Scientists theorize that this strategy is highly energy efficient, allowing the fish to conserve metabolic resources by not actively pursuing food or expending energy in continuous evasion from predators. Instead, it lets the world come to it, a testament to the power of passive existence. Beyond its visual and behavioral adaptations, some researchers ponder if the stonefish employs other, more subtle forms of camouflage. Could it minimize its electrical signature, making it harder for electroreceptive predators like sharks to detect its presence? While direct evidence for this is less conclusive, it is a fascinating area of ongoing study into the full spectrum of sensory concealment. The very mucus that coats its body, which also plays a role in venom delivery, might also help mask its chemical scent, allowing it to become truly invisible in a multi-sensory way to the diverse inhabitants of the reef. The evolutionary pressures that sculpted this master of disguise are immense and multifaceted. On one hand, it faces the constant threat of predation from larger fish sharks and even certain marine birds when it ventures into very shallow waters. Its camouflage is its primary defense against being noticed and consumed. On the other hand, it is a hunter, and its survival depends on its ability to capture prey. By blending seamlessly into its environment, it creates a perfect trap. Small fish crabs and shrimp foraging along the seabed swim or crawl blithely past what they perceive as a harmless rock, only to be engulfed in a lightning-fast strike when they venture too close. This dual advantage, protection from predators and efficiency in hunting, has driven the stonefish down an evolutionary path of unparalleled mimicry. The danger this poses to humans stems directly from the perfection of its disguise. A barefoot wader stepping into the shallows, a snorkeler reaching for what appears to be an interesting rock, a diver momentarily brushing against the seabed. These are the moments when the stonefish's art of disappearing tragically collides with human presence. The creature is not aggressive. Its sting is purely a defensive reflex, triggered by pressure. It is the very success of its camouflage that makes it so perilous, as it denies the human eye the crucial information needed for avoidance. It is a living embodiment of the adage that what you don't see can indeed harm you. As we allow these intricate details of its vanishing act to settle within our minds, we begin to appreciate the profound intelligence of nature, the countless millennia of trial and error that have refined such a specialized existence. The stonefish, in its motionless vigil, whispers secrets of adaptation, of survival, and of the astonishing beauty that can be found even in the most deceptively ordinary forms. This deep understanding of its camouflage now prepares us to explore the specific environments where this silent sentinel chooses to reside, its preferred realms within the vast, whispering ocean. Habitats and hidden realms. As the intricate details of its vanishing act slowly recede into the gentle currents of your thoughts, we now turn our quiet contemplation toward the very stage upon which this master of disguise performs its eternal, silent drama. We drift into the realms where the stonefish chooses to reside, the hidden corners and sun-dappled shallows that form its world, its home, beneath the gentle waves. The primary domain of the stonefish stretches across the vast, warm expanse of the Indo-Pacific Ocean, a shimmering liquid tapestry that embraces tropical and subtropical latitudes. Imagine a curved arc spanning thousands of kilometers, beginning from the sun-baked shores of the Red Sea and the eastern coast of Africa, flowing eastward across the immense blue of the Indian Ocean, through the intricate archipelagos of Southeast Asia, and extending far into the boundless Pacific, reaching as distant as the island chains of French Polynesia and the southern coasts of Japan. Within this immense geographical range, the stonefish is not uniformly distributed, but rather selects specific microhabitats that cater to its unique blend of camouflage and ambush predation. Its most favored realms are the vibrant, complex ecosystems of coral reefs. Allow your mind to envision a coral city built over millennia by countless tiny polyps, a sprawling metropolis of calcified structures. Here, amidst the branching fingers of staghorn coral, the convoluted patterns of brain coral, and the plate-like formations of table coral, the stonefish finds an abundance of nooks, crannies, and textured surfaces. The reef floor is a kaleidoscope of shapes and shadows, a mosaic of living polyps, dead coral skeletons, and the inevitable detritus of marine life. This visual complexity is precisely what the stonefish requires. It will settle itself into a shallow depression, perhaps beside a weathered coral head, or against the rough flank of a large boulder, its irregular skin merging flawlessly with the surrounding textures. The interplay of light filtering through the water, creating shifting patterns of brilliance and gloom, further aids its disguise, making its outline shimmer and dissolve into the background. Here, it becomes just another feature of the reef, an inert part of the vibrant breathing whole, waiting for the unsuspecting smaller fish and crustaceans that navigate these intricate pathways. Beyond the bustling coral metropolis, the stonefish also gravitates towards rocky outcrops and volcanic shores. Picture a coastline where ancient volcanic activity has left behind a rugged landscape, even beneath the waves. Submerged boulders, jagged rocks, and shelves of solidified lava create a different kind of textured environment. These areas are often characterized by tide pools, shallow depressions that become isolated from the main ocean at low tide, or intertidal zones where the water ebbs and flows with the rhythm of the moon. In these rocky realms, the stonefish's coloration, often a blend of dark greys, browns, and greens, allows it to mimic the mineral composition of the stone itself, becoming an indistinguishable part of the geological formation. It will wedge itself between rocks or settle flat against a stone surface, its broad, flattened body pressing tightly, eradicating any telltale shadows. These rocky habitats, especially in the intertidal zone, are particularly perilous for humans, as unsuspecting waders or rock pool explorers might inadvertently step upon a perfectly camouflaged stonefish. Furthermore, the stonefish is not exclusively confined to hard, rocky substrates. It demonstrates a remarkable adaptability, often found partially buried in sandy or muddy bottoms, particularly in areas adjacent to reefs or rocky shores. Imagine a patch of fine, silty sand stirred gently by the currents, where only the faintest ripples mark the seabed. Here, the stonefish will use its broad pectoral fins and body movements to excavate a shallow depression, settling itself into the sediment until only its eyes and perhaps the very tips of its dorsal spines are visible above the surface. Its mottled, earthy tones blend seamlessly with the hues of the sand or mud, and the soft, diffused light of the shallows further aids its concealment. This ability to bury itself provides an additional layer of camouflage, turning it into an almost invisible mound, a subtle irregularity in the otherwise smooth expanse of the seabed. Prey animals sifting through the sand for food or simply swimming close to the bottom would perceive only an inert patch of sediment, unaware of the living trap beneath. The depth preference of the stonefish is generally quite shallow. While some individuals have been observed at depths of up to 40 meters, the vast majority thrive in the euphotic zone, the upper layer of the ocean where sunlight penetrates. This includes the intertidal zone, where water depth can range from mere centimeters to a few meters, making these areas particularly accessible to humans engaging in recreational activities such as swimming, snorkeling, or simply walking along the shoreline. The warm, well-lit waters of these shallow environments are rich in the small fish and invertebrates that constitute its diet, and the abundance of complex structures, whether coral rock or sediment, provides ample opportunity for its ambush hunting strategy. The environmental factors that define these habitats are consistently warm, tropical to subtropical water temperatures, typically ranging from around 20 to 30 degrees Celsius. While primarily a marine fish, some species of stonefish can tolerate brackish water for short periods, suggesting an occasional foray into the fringes of mangrove estuaries or river mouths, though these are less common primary habitats. The water clarity can vary, but even in slightly turbid waters, its camouflage remains effective as visual cues become even more muddled, further aiding its disappearance. The currents in its preferred resting spots are generally moderate to low, as strong currents would make it difficult for the fish to maintain its motionless vigil and risk dislodging it from its chosen ambush site. Ecologically, the stonefish occupies a critical niche as an ambush predator and a master of passive defense. Its presence contributes to the intricate balance of the reef ecosystem, helping to regulate populations of smaller fish and invertebrates. It is a testament to the power of specialization, a creature that has honed a singular strategy, that of absolute stillness and ultimate defense, to perfection. Its very existence shapes the behavior of other reef dwellers, even if they are unaware of its precise location. The constant, subtle caution exercised by reef fish and crustaceans is in part a response to the unseen dangers, the hidden predators, like the stonefish that lie in wait. These hidden realms, so seemingly peaceful and inviting, hold within them the silent vigilance of the stonefish. Its choice of habitat is not arbitrary. It is a meticulously evolved strategy, a deep biological imperative that guides it to precisely those environments where its unique attributes, its unparalleled camouflage, its profound stillness, and its potent venom can be maximized for survival. As we allow these images of its chosen homes to settle within our minds, we begin to appreciate the intricate connection between a creature and its environment, a bond forged over millions of years of adaptation. This understanding now gently leads us to explore the very core of its formidable defense, the anatomical marvels that house and deliver its potent liquid secret. Anatomy of a lethal defense. As the images of its chosen homes, those hidden realms beneath the gentle waves, slowly recede into the quiet chambers of your mind, we now turn our unwavering gaze toward the very core of the stonefish's formidable defense. We shall explore the intricate anatomical marvels that house and deliver its potent liquid secret, focusing our attention on those deceptively rugged structures along its back, the dorsal daggers. Observe the stonefish as it rests a motionless sculpture on the seabed. Its dorsal fin, unlike the graceful fanning structures of many other fish, is not designed for elegant propulsion or vibrant display. Instead, it presents itself as a series of profoundly stout, almost blunt-looking spines, typically 13 in number, though variations can occur. These are not delicate filaments, but rather robust, bone-hard structures, each one a miniature, unyielding spear. When the fish is undisturbed, these formidable spines lie partially recessed, almost folded flat against its broad, lumpy back, seamlessly integrating into the chaotic topography of its skin. They become just another irregular ridge, another knobbly protrusion in the overall texture of its camouflaged form, further obscuring any hint of a living creature. Yet within the seeming inertness of these spines lies a sophisticated biological weapon, meticulously refined over countless millennia of evolution. Each of these 13 dorsal spines is a complex apparatus, a marvel of defensive engineering. Imagine each spine as a solid, bony rod, tapering gradually from its thick base to an exceptionally sharp, almost needle-like point. Along the sides of this central, bony shaft, running longitudinally from the base, almost to the tip, are two distinct grooves. These grooves are not merely decorative, they are the precisely engineered conduits for the stonefish's venom. Nestled snugly within these grooves at the base of each spine are the venom glands themselves. These are not just simple sacs, but specialized glandular tissues, typically two elongated pear-shaped structures, one situated within each groove. Within these glands, specialized secretory cells tirelessly produce the complex cocktail of toxins that defines the stonefish's legendary potency. The venom in its natural state within these glands is a milky, viscous fluid, a concentrated biological weapon awaiting its moment of deployment. The glands are encased within a delicate yet surprisingly resilient integumentary sheath, a thin, fleshy membrane that completely envelops each spine when it is at rest. This sheath is a crucial component of the delivery system, and indeed of the stonefish's camouflage, as its irregular surface and coloration perfectly blend with the surrounding skin, further concealing the lethal apparatus beneath. Now let us trace the precise, almost mechanical sequence of events that unfolds when this silent sentinel is threatened. The stonefish does not actively attack. Its venom is purely a defensive measure, triggered by direct pressure. Imagine an unsuspecting wader inadvertently stepping upon the camouflaged fish, or a curious diver brushing against its seemingly inert form. The moment pressure is applied to the stonefish's back, particularly over its dorsal fin, a powerful reflex is initiated. The stonefish, instead of attempting to flee, responds by instinctively erecting its dorsal spines. These 13 bone-hard daggers, which minutes before lay partially concealed, now spring upwards, becoming rigid and formidable, pointing directly outward from its body like a defensive palisade. As the pressure from the external force, such as a human foot, continues to bear down upon the erected spines, a critical mechanical action occurs. The integumentary sheath, that thin, fleshy membrane covering each spine, is compressed. This compression forces the sheath to retract, and crucially, to rupture at its delicate, needle-sharp tip. Think of it like a tiny, biological, hypodermic needle, where the outer casing is pushed back, exposing the sharp point and simultaneously squeezing the contents. As the sheath tears and slides back, the exposed razor-sharp tip of the spine penetrates the skin of the victim. Simultaneously, the continued pressure on the base of the spine compresses the venom glands nestled within their grooves. This compression, much like squeezing a tube, forces the milky, viscous venom to be ejected from the glands flowing down the grooves along the spine and directly into the wound created by the penetrating tip. The depth of penetration and the amount of venom delivered are directly proportional to the force and duration of the pressure applied. A light brush might result in a superficial scratch and only a small dose of venom, while a full step can drive the spines deep into the tissue, injecting a significant and devastating amount of the potent toxin. The robustness of these spines is also a key evolutionary advantage. They are designed to withstand considerable force without breaking, ensuring effective venom delivery even in the face of significant impact. This ensures that the defense mechanism is reliable and potent, delivering its full effect when truly threatened. While the dorsal spines are undeniably the primary and most significant venom delivery system, some species of stonefish, and indeed other members of the broader scorpionfish family, may possess venom glands associated with other fins, such as the anal or pelvic fins. However, in the true stonefish's Cynancea genus, the dorsal spines are overwhelmingly the source of the most potent and clinically significant envenomations. The sheer number size and efficient design of these 13 dorsal daggers make them the undisputed focal point of its lethal defense. Further enhancing its defensive capabilities, the stonefish's entire body, including its spines, is often covered in a thick protective layer of mucus. This mucus, in addition to contributing to its camouflage by obscuring its texture, may also play a role in protecting the delicate venom glands from infection or damage. It might also reduce friction during the spine's penetration, allowing for a smoother, more efficient injection of venom. This coating also aids in preventing desiccation when the stonefish is exposed during low tide, highlighting the multifunctional nature of its biological adaptations. The evolution of such a specialized and potent defensive system speaks volumes about the environmental pressures faced by the stonefish. As an ambush predator that relies on absolute stillness, it cannot outrun or actively fight off larger predators. Instead, it developed a passive yet instantly active deterrent. Its defense is always ready, requiring no conscious decision to engage only the mechanical stimulus of pressure. This strategy is incredibly energy efficient, as it does not expend metabolic resources in flight or direct confrontation. It simply is a danger, and that danger is universally understood by the nervous systems of anything large enough to threaten it, or tragically, to step upon it. This ensures that a single painful encounter is often enough to teach a predator or a human a lasting lesson, reinforcing the stonefish's unchallenged position as a formidable if unseen guardian of its chosen patch of reef. As we gently absorb the intricate details of these dorsal daggers, we gain a deeper appreciation for the complex interplay between form and function in the natural world. The stonefish is a living testament to the power of specialized adaptation, a creature that has honed its defensive anatomy to a chilling perfection. This understanding of its physical defenses now prepares us to journey into the very essence of its potency, the complex, liquid labyrinth of its venom, and the profound effects it unleashes upon the unsuspecting. Decoding the stonefish venom. As the intricate architecture of the dorsal daggers slowly fades from the forefront of your awareness, we now embark on a profound journey inward, delving into the very essence of the stonefish's lethal power, the complex liquid labyrinth of its venom. This is not merely a simple irritant, but a sophisticated biological cocktail, a marvel of biochemical engineering refined over countless millennia, designed to inflict immediate, overwhelming pain and systemic disruption. Imagine, if you will, this venom not as a single substance, but as a microscopic universe of interacting molecules, each playing a specific, devastating role. The primary active component, the undisputed orchestrator of its most severe effects, is a large protein known as Stonus toxin. This formidable molecule, a true masterpiece of destructive biochemistry, is specifically found in species such as Sinansia horrida. It is a multi-subunit protein, meaning it is composed of several smaller protein chains intricately folded and linked together, forming a complex structure. This complexity is key to its potency, allowing it to interact with living cells in a highly specific yet profoundly damaging manner. The mechanism of Stonus toxin is insidious in its elegance. Scientists believe that upon entering the bloodstream or tissue, this protein immediately seeks out the delicate outer membrane of living cells. It acts as a potent cytolysin, a cell-destroying agent. Visualize its action. The Stonus toxin molecule adheres to the cell membrane, then undergoes a subtle conformational change, a tiny shift in its three-dimensional shape. This change allows it to insert itself directly into the lipid bilayer of the cell membrane, the very boundary that defines the cell's integrity. Once inserted, it doesn't just sit there. It begins to aggregate together with other Stonus toxin molecules, forming microscopic yet devastating pores or channels. Think of these pores as tiny, uncontrolled gateways suddenly punched through the protective wall of a fortress. Normally, cell membranes meticulously regulate the passage of ions, electrically charged atoms like sodium, potassium, and calcium, maintaining a delicate electrochemical balance essential for cellular function. But when Stonus toxin creates these pores, this meticulous regulation is violently overthrown. There is a sudden, uncontrolled influx of sodium and calcium ions into the cell, and a rapid efflux of potassium ions out of the cell. This massive chaotic ion exchange fundamentally disrupts the cell's electrical potential, a process known as depolarization. For nerve cells, this means agonizing, uncontrolled firing, sending signals of intense pain. For muscle cells, it means spasms and paralysis. And for all cells, this osmotic imbalance causes water to rush in, swelling the cell, until its delicate membrane can no longer withstand the pressure, causing it to rupture, to burst open like a tiny, overfilled balloon. This is cell lysis, the direct destruction of tissue at the site of envenomation, manifesting as profound local pain swelling and eventual tissue necrosis. Closely related to Stonefish toxin is verrucotoxin, another potent cytolysin found in species like Cynansia verrucosa. While possessing slight variations in its molecular structure, verrucotoxin shares the same core destructive mechanism, the formation of pores in cell membranes leading to rapid cellular destruction, and the cascade of physiological effects that follow. The evolutionary success of this pore-forming strategy is evident across the stonefish genus, underscoring its efficiency as a defensive weapon. But the liquid labyrinth is not solely composed of these powerful cytolysins. The venom also contains a range of other active components, each contributing to the overall devastating effect. One such component is hyaluronidase. This is an enzyme, a biological catalyst that specializes in breaking down hyaluronic acid. Hyaluronic acid is a crucial component of the extracellular matrix, the glue, that binds cells together and forms the connective tissue scaffolding throughout the body. By dissolving this glue, hyaluronidase acts as a spreading factor. Imagine the venom once injected as a determined liquid pioneer, dissolving the very pathways and barriers that would normally restrict its movement. This allows the other toxic components, particularly the larger protein toxins, to diffuse more rapidly and widely through the tissues, accelerating the onset of systemic effects and expanding the area of local destruction. Beyond these major players, the stonefish venom also contains a complex array of other substances. There are various proteases enzymes that break down other proteins, contributing to the significant tissue damage and necrosis observed in severe stings. These proteases can chew through cellular structures, exacerbating the destruction initiated by the cytolysins. Furthermore, the venom can contain histamine-releasing factors, which directly stimulate the body's mast cells to release histamine. Histamine is a powerful inflammatory mediator responsible for many of the immediate symptoms of a sting: intense redness, localized heat, pronounced swelling, and an amplification of the already excruciating pain. This localized inflammatory response is a natural defense mechanism gone awry, becoming part of the venom's destructive toolkit. From a broader physiological perspective, the stonefish venom can be categorized by its multifaceted effects. It is primarily a cytotoxin, as we've discussed, causing direct cell destruction and tissue necrosis at the site of injection. This accounts for the immediate agonizing pain and the profound local tissue damage. However, its effects extend far beyond the immediate wound. Stonefish toxin and verrucotoxin also exhibit neurotoxic properties. By disrupting the delicate ion balance across nerve cell membranes, they interfere with the transmission of nerve impulses. This can lead to a range of neurological symptoms, from muscle weakness and spasms in the affected limb to more generalized paralysis in severe cases. The agony itself is a neurotoxic effect, an overwhelming assault on the pain receptors. Moreover, the venom possesses significant cardiotoxic effects. The disruption of ion channels, particularly calcium channels, can directly impact the highly specialized muscle cells of the heart. This can lead to arrhythmias, an irregular heartbeat, and a profound drop in blood pressure known as hypotension. In the most severe cases, this cardiotoxicity can culminate in cardiac arrest, making stonefish envenomation a potentially fatal event if left untreated. The systemic spread of these toxins, facilitated by hyaluronidase, allows them to reach the heart and central nervous system, transforming a localized injury into a life-threatening emergency. The sheer intensity of pain reported by victims of stonefish stings is a direct testament to the rapid and devastating action of this venom. It is described not merely as a sharp jab, but as an immediate, escalating, burning and throbbing agony that spreads rapidly from the point of injection. Victims often describe it as feeling like the limb is being crushed or set on fire from the inside, an unbearable sensation that can drive individuals to delirium, to beg for amputation, simply to escape the torment. This level of pain is a direct consequence of the widespread cellular destruction and nerve irritation, occurring simultaneously at the molecular level, a biological alarm bell ringing with deafening intensity. It is crucial to understand that the potency and severity of a stonefish sting are influenced by several factors. The species of stonefish can play a role with Cynancea horrida and Cynancea verrucosa being particularly notorious. The size of the fish can also matter, as larger individuals generally possess more venom. Critically, the depth of spine penetration and the amount of venom actually injected are paramount. A superficial scratch will be less severe than a deep puncture. The location of the sting also influences outcome. A sting near a major blood vessel or nerve can accelerate systemic absorption and amplify effects. Finally, individual victim factors such as body mass, age, general health, and any pre-existing sensitivities can modulate the response. As we slowly withdraw from this microscopic exploration of the liquid labyrinth, we are left with a profound appreciation for the intricate, deadly chemistry that defines the stonefish's ultimate defense. This complex biological weapon, a testament to evolutionary pressures, underscores the hidden dangers and scientific wonders that lie concealed beneath the tranquil surface of the ocean. This detailed understanding of its venom now prepares us to confront the immediate and cascading physiological consequences that unfold within the human body following such an encounter. The physiological cascade of a sting, as the intricate, deadly chemistry of the stonefish venom settles within the quiet pools of our understanding. We now allow our awareness to gently shift to follow that potent liquid as it begins its insidious journey within a living body. We explore in slow, deliberate contemplation the physiological cascade, the profound unraveling that commences the moment a stonefish spine delivers its searing payload. Imagine, if you will, the instant of impact a foot descends, or a hand brushes against what seems to be an inert rock. The spine, a hardened dagger, pierces the skin, a sharp, sudden intrusion. In that precise fraction of a second, the venom, that complex liquid labyrinth we have just explored, is injected into the delicate tissues beneath. The initial sensation is not merely a prick, but an immediate searing pain, a shockwave of agony that radiates outwards from the point of entry. It is often described as feeling like a white-hot ember has been plunged into the flesh, a sensation of intense burning pressure that instantly demands the body's full, terrified attention. This initial excruciating pain is the direct consequence of the venom's immediate assault on the cellular level. The cytolysins like stonostoxin and verrucotoxin begin their destructive work almost instantaneously. They attach to the membranes of local nerve cells, muscle cells, and blood vessel cells, punching those microscopic pores, causing a violent disruption of their electrochemical balance. nerve endings exquisitely sensitive to such cellular trauma fire, wildly sending a deluge of pain signals racing along the neural pathways towards the brain. Simultaneously, the direct lysis, the bursting of cells, releases a cascade of inflammatory mediators from the damaged tissue, further amplifying the pain response and initiating the body's frantic, yet often counterproductive, defensive mechanisms. Within moments, the local area around the puncture site begins to undergo dramatic changes. Observe the skin. It rapidly becomes intensely red, a flush of angry crimson spreading outwards, indicative of profound vasodilation, where local blood vessels expand in a desperate attempt to bring healing factors to the site. This redness is accompanied by an equally rapid and pronounced swelling, a palpable distension of the tissue, as fluid from the capillaries leaks into the interstitial spaces, the areas between cells, in response to the cellular damage and inflammation. The affected limb might feel heavy, stiff, and incredibly tender to the slightest touch. Sometimes a curious blanching, a pale halo can be observed immediately around the puncture point, a localized vasoconstriction in response to the venom contrasting starkly with the surrounding redness. As minutes stretch into what feels like an eternity, the pain intensifies, escalating beyond mere discomfort into a realm of unbearable torment. Victims often describe it as a deep, throbbing agony, as if the limb is being crushed or gnawed from within a relentless, unyielding assault that can drive even the most stoic individuals to tears, to delirium, or as harrowing accounts reveal, to beg for the affected limb to be amputated simply to escape the ceaseless suffering. This profound pain is a signature of stonefish envenomation, a testament to the venom's ability to overwhelm the body's pain processing systems. Beyond the immediate agony, the venom's components, particularly the hyaluronidase, begin their work of spreading. This enzyme, dissolving the connective tissue matrix, facilitates the rapid diffusion of the larger protein toxins away from the initial puncture site. The venom then enters the lymphatic system, a network of vessels that drains fluid from tissues and subsequently into the bloodstream, where it begins its devastating journey throughout the entire body. As the toxins circulate, they unleash a systemic cascade of physiological disruptions. One of the most critical and dangerous effects is on the heart cardiovascular system. The cardiotoxic components of the venom directly interfere with the delicate electrical impulses that govern the heart's rhythm and the contractility of its muscle cells. This can lead to a sudden and profound drop in blood pressure known as hypotension. Imagine the body's vital organs, particularly the brain, suddenly being deprived of adequate blood flow. The victim might experience overwhelming dizziness, lightheadedness, a sensation of profound weakness, and a terrifying feeling of impending collapse. The heart might struggle, manifesting as arrhythmias, an irregular fluttering or pounding heartbeat, or even bradycardia, an abnormally slow heart rate as the venom directly depresses cardiac function. In the most severe cases, this cardiotoxicity can culminate in circulatory shock, where the body's organs fail due to insufficient blood supply, potentially leading to cardiac arrest and death. Simultaneously, the nervous system, already reeling from the localized assault, begins to exhibit more generalized symptoms. The neurotoxic elements of the venom can induce widespread muscle weakness, leading to difficulty moving the affected limb, and in severe cases, generalized paralysis. Muscle spasms, involuntary contractions that ripple through the limb, add another layer of discomfort. Systemic absorption of the venom can also trigger nausea and profuse vomiting, often accompanied by severe abdominal pain, as the autonomic nervous system reacts violently to the overwhelming physiological stress. Headaches, often described as pounding or splitting, further compound the misery, accompanied by dizziness, confusion, and a general disorientation as the brain struggles under the combined assault of pain, hypertension, and circulating toxins. In the most extreme and rare instances, particularly in very young, elderly, or immunocompromised individuals, convulsions may occur, signaling severe central nervous system involvement. The body's overall response to such a profound insult is one of extreme distress. Profound sweating, a cold, clammy sheen across the skin, is a common autonomic reaction to intense pain and systemic shock. The victim may experience chills or even develop a fever as the body's immune system mounts a generalized inflammatory response. Lymph nodes, those small bean-shaped glands that filter the lymphatic fluid, particularly those in the groin or armpit nearest the sting, may become swollen and tender, working overtime to process the circulating toxins. A pervasive sense of malaise and overwhelming fatigue descends upon the individual, leaving them utterly drained and depleted. As hours pass, the local tissue damage continues its grim progression. The profound cytotoxicity and localized inflammation often lead to tissue necrosis, the death of cells and tissue at the site of injection. The skin around the puncture wound may darken, turning purplish or black, and eventually begin to slough off, leaving behind a raw, open wound. This necrotic tissue is not only painful but also creates a fertile ground for secondary bacterial infections, further complicating the recovery process and potentially leading to cellulitis, abscess formation, or even sepsis if left untreated. Healing can be a slow, arduous process, often leaving behind significant scarring, and in some unfortunate cases, permanent nerve damage or muscle atrophy in the affected limb. The physiological unraveling caused by a stonefish sting is a testament to the venom's complex design, a multi-pronged assault that targets multiple organ systems simultaneously. It is a stark reminder of the hidden power that resides within the seemingly inert forms of nature, a power capable of transforming a moment of inattention into a life-threatening ordeal. As we allow the profound gravity of this physiological cascade to gently settle within our minds, we turn our attention now to the crucial immediate responses, the life-saving measures that can slow this unraveling and offer a pathway back from the brink. Immediate responses to envenomation. As the profound gravity of the body's unraveling, the systemic cascade unleashed by stonefish venom, gently settles within the quiet pools of your understanding. We now turn our focus to the critical moments immediately following such an encounter. We explore with deliberate calm the immediate responses, the life-saving measures that can slow the relentless current of the venom's progression, offering a pathway back from the brink of extreme suffering and potential danger. Imagine the sudden piercing agony, that initial shockwave of pain we described. The very first instinctive reaction for anyone unfortunate enough to step upon a stonefish must be to withdraw from the water. This is not merely about escaping the immediate source of danger, but about ensuring personal safety and preventing further injury. The seabed, which moments before seemed benign, might conceal other dangers, and the initial disorientation from the sting can impair judgment. So with as much calm as can be mustered amidst the burgeoning pain, the affected individual must be guided or helped to shore away from the unpredictable movements of the ocean. Once safely out of the water, the immediate attention shifts to the wound itself. With gentle hands and a focused gaze, the area of envenomation must be carefully inspected. The stonefish's spines are incredibly robust, but in rare instances a fragment of a spine or even a piece of the venomous integumentary sheath might remain embedded in the tissue. These fragments, if present, should be carefully removed using tweezers if readily available, and visible, taking extreme care not to further traumatize the wound or push any material deeper. This delicate act of removal is about preventing a lingering source of irritation and potential infection, though the primary venom delivery has already occurred. Cleansing the wound gently with clean water and mild soap, if available, can help to remove any surface contaminants, minimizing the risk of secondary bacterial infection. This is not about neutralizing the venom which is already deep within the tissues, but about wound hygiene. Now we arrive at the cornerstone of Stonefish First Aid, a method both remarkably simple and profoundly effective. Hot water immersion. This technique, refined through years of observation and scientific understanding, exploits a crucial vulnerability of the stonefish venom. The primary protein toxins, stonostoxin and verrucotoxin, are what scientists term thermolabile. This means they are sensitive to heat. Their complex three-dimensional structures, which are essential for their toxic function, begin to unravel and denature when exposed to sufficiently high temperatures. Think of an egg white, clear and liquid, solidifying and turning opaque when heated. Its proteins have denatured, irreversibly losing their original structure and function. Similarly, the heat from the water begins to dismantle the venom proteins, rendering them inert, unable to continue their destructive work. The process is precise and requires careful attention. The affected limb, whether it be a foot, hand, or arm, should be gently yet swiftly immersed in water that is as hot as the victim can comfortably tolerate without causing scalding. The ideal temperature range is typically between 40 and 45 degrees Celsius, 104 to 113 degrees Fahrenheit. It is crucial to test the water temperature with an unaffected part of the body first, or to have another person test it to prevent additional injury from burns. The pain from the sting is so intense that the victim's sensation of heat might be compromised, making careful temperature regulation paramount. As the limb enters the hot water, an initial surge of amplified pain might be experienced, a momentary protest from the inflamed tissues. But this is often quickly followed by a gradual, profound easing of the agony. Imagine the relentless throbbing which moments before felt like a hammer striking from within, slowly receding, replaced by a more bearable, though still profound, discomfort. This relief is the tangible sign that the heat is working, that the venom proteins are beginning to unravel. The immersion should be maintained for a minimum of 30 to 90 minutes, or until significant pain relief is achieved, and often even longer if the pain persists. It is vital to continuously replenish the hot water, or use a method to maintain its temperature, such as a heating element, or by carefully adding more hot water, as the water will naturally cool. This sustained heat exposure is key to effectively denaturing the venom. While the hot water immersion is underway, attention should also be given to pain management beyond the heat. The sheer intensity of stonefish pain can induce panic, anxiety, and even shock. Reassurance, a calm and steady presence, is invaluable. The victim should be encouraged to breathe deeply and slowly, to focus on the gradual easing of the pain from the hot water. Over-the-counter pain relievers, if available and appropriate for the individual, such as ibuprofen or paracetamol, can be administered, though their effect will likely be minimal against the initial overwhelming pain. Elevation of the affected limb, if comfortable and not interfering with the hot water treatment, can sometimes help to reduce swelling by facilitating lymphatic drainage. But this is secondary to the heat treatment. It is equally important to address what not to do. Folk remedies often steeped in superstition or misunderstanding can be not only ineffective but actively harmful. Attempting to suck the venom out of the wound, cutting the wound, or applying substances like urine kerosene or traditional poultices are all strongly discouraged. These actions do not remove or neutralize the venom, and they significantly increase the risk of infection, further tissue damage, and delay proper medical treatment. Similarly, the application of cold packs or ice is contraindicated as cold can cause vasoconstriction, constricting blood vessels and potentially concentrating the venom, locally hindering its breakdown and delaying its systemic removal, as well as exacerbating tissue damage. Another critical point to understand is the use of aru tourniquets or constrictive bandages. While these might seem intuitively helpful to prevent venom spread, they are generally not recommended for stonefish stings. A tightly applied tourniquet can completely cut off blood flow to the limb, leading to severe tissue damage, nerve injury, and even the potential for amputation if left on for too long. While some medical protocols for certain snake bites or other venoms might involve pressure, immobilization for stonefish, the primary concern is the rapid local tissue destruction and intense pain, which hot water addresses most effectively without the risks associated with constriction. If a pressure bandage is applied, it must be loose enough to allow blood flow, and its efficacy in stonefish envenomation is debatable compared to the proven benefits of heat, regardless of the immediate relief provided by hot water. Seeking professional medical attention is paramount and non-negotiable. The hot water treatment is a first aid measure designed to mitigate the immediate pain and slow the venom's progression, but it is not a cure. Systemic effects such as hypotension, cardiac arrhythmias, and severe neurological symptoms can still develop or worsen, especially if a large amount of venom has been injected. Therefore, arrangements for transportation to the nearest medical facility should be made as soon as possible, ideally while the hot water immersion is still ongoing. During transport or while waiting for medical personnel, continuous monitoring of the victim is crucial. Observe for any signs of worsening systemic envenomation, increasing dizziness, profound weakness, nausea, vomiting, sweating, difficulty breathing, changes in heart rate, or any signs of altered consciousness. These are indicators that the venom is circulating and affecting vital organ systems, necessitating urgent medical intervention. The psychological state of the victim also requires ongoing attention. The intense pain can be profoundly traumatizing, and continued reassurance is essential. The development of hot water immersion as the primary first aid for stonefish stings is a testament to empirical observation, refined by scientific understanding. Historically, coastal communities likely discovered its benefits through trial and error, realizing that heat provided relief. Modern science has since elucidated the biochemical basis, confirming the thermolabile nature of the toxins. This simple, accessible, yet remarkably effective treatment remains the gold standard for immediate care, a bridge of comfort over the turbulent waters of envenomation. As we gently absorb the critical steps of these immediate responses, allowing them to settle like calm currents within our minds, we are prepared to move beyond first aid. We turn our attention now to the advanced medical interventions, the scientific countermeasure developed to directly combat the venom's effects, the Antivenom, a beacon of hope in the face of such profound biological hostility. Medical science's countermeasure. As the critical steps of immediate response, the soothing embrace of hot water gently settle within the quiet currents of your mind. we now transcend the realm of first aid. We turn our focused attention toward a profound achievement of medical science, a specific countermeasure meticulously crafted to directly combat the venom's destructive embrace, the Antivenom. This is a beacon of hope, a carefully engineered biological shield against the stonefish's potent liquid secret. While the comforting warmth of hot water can offer profound, often life-saving relief from the initial agonizing pain and can slow the local progression of tissue damage, it is ultimately a symptomatic treatment. It does not, in itself, neutralize the venom that has already entered the bloodstream and begun its systemic journey. For those individuals experiencing severe pain, unresponsive to heat, or more critically for those exhibiting the alarming signs of systemic envenomation, the plummeting blood pressure, the irregular heart rhythms, the profound weakness, the nausea, the collapse. A more direct molecular intervention is urgently required. This is where the Antivenom steps forward, a testament to humanity's persistent quest to understand and counteract the deadliest forces of nature. Imagine, if you will, a careful, deliberate process where the very venom itself becomes the key to its own undoing. The development of Antivenom is a sophisticated dance between biological understanding and pharmaceutical precision. It begins with the careful collection of stonefish venom extracted from the fish in controlled scientific environments. This raw venom, once purified, becomes the crucial antigen, the substance that will provoke an immune response. Next, this purified venom is administered in minute, carefully controlled and progressively increasing doses to a large, healthy animal, typically a horse. The horse, with its robust immune system and substantial blood volume, serves as a living antibody factory. Over a period of several months, as the horse is repeatedly exposed to the venom, its immune system recognizes the foreign proteins as a threat. In response, it begins to produce specialized proteins called antibodies. These antibodies are exquisitely precise, custom-designed molecules that are capable of specifically binding to and neutralizing the venom's toxins. Think of them as tiny biological locks, each perfectly shaped to fit and disable a particular venomous key. Once a sufficient level of these protective antibodies has been generated within the horse's bloodstream, a small, carefully monitored amount of blood is drawn. From this blood, the plasma, the liquid component rich in antibodies, is separated. This crude plasma then undergoes a rigorous purification process. Modern antivenom production often involves fragmenting these antibodies, typically isolating the Fab fragment, antigen-binding portions. These smaller Fab fragments are highly effective at binding venom, and by removing the larger non-binding parts of the antibody, the risk of adverse allergic reactions in the human recipient can be significantly reduced, making the antivenom safer and more tolerable. The final product is a sterile, clear or pale amber liquid, concentrated with these potent venom-neutralizing antibodies. The mechanism of action of stonefish antivenom is elegantly direct. Once administered to a human victim, these purified antibodies circulate throughout the bloodstream. Their mission is clear: to seek out and bind to the free venom molecules, the stonus toxin, the verocotoxin, and other active components that are still circulating and actively causing harm. When an antibody binds to a venom toxin, it effectively neutralizes it. This binding prevents the toxin from attaching to and disrupting cell membranes from forming those destructive pores, and from interfering with nerve and heart function. The antibody-venom complex is then too large or too altered to interact with the body's cells, and it is subsequently recognized and cleared from the body by the immune system, often through the kidneys and liver. Essentially, the antivenom acts as a molecular mop, sweeping up and deactivating the circulating venom, preventing further cellular destruction and systemic damage. The decision to administer antivenom is a critical medical judgment made by healthcare professionals based on the severity of the envenomation. It is typically indicated in cases where the pain is severe and persistent, showing little or no response to prolonged hot water immersion. More importantly, antivenom is crucial when systemic signs of envenomation begin to manifest: a significant drop in blood pressure, hypotension, cardiac arrhythmias, irregular heartbeats, profound muscle weakness or paralysis, severe nausea and vomiting, or any signs of altered consciousness or circulatory collapse. It may also be considered in cases of extensive and rapidly progressing local tissue necrosis to minimize further damage. The administration of stonefish antivenom is always performed in a controlled medical setting, usually intravenously, meaning it is slowly infused directly into a vein. The dosage is carefully calculated by the treating physician, often based on the patient's symptoms and the perceived severity of the sting, not necessarily on body weight. An initial dose, typically 1 or 2 ampules, is infused slowly, allowing medical staff to closely monitor for any immediate adverse reactions. If systemic symptoms persist or worsen after the initial dose, additional ampules may be administered. The effects of the antivenom can be remarkably swift and dramatic. Victims often report a profound reduction in pain, sometimes within minutes to an hour of the infusion beginning, as the circulating venom is rapidly neutralized. Systemic symptoms also begin to reverse. Blood pressure stabilizes heart rhythm, improves muscle weakness, recedes, and the debilitating nausea and vomiting often subside. This rapid clinical improvement is a powerful testament to the antivenom's efficacy, often bringing a wave of profound relief to the suffering individual. However, like any powerful medical intervention, the antivenom's embrace is not entirely without its delicate complexities and potential risks. Because stonefish antivenom is derived from horse serum, it contains foreign animal proteins. This can trigger allergic reactions in some individuals. The most immediate and severe of these is anaphylaxis, a life-threatening generalized allergic response. Anaphylaxis can manifest rapidly with symptoms such as a sudden drop in blood pressure, difficulty breathing, dew swelling of the airways, bronchospasm, widespread hives, or rash and swelling of the face and throat. To mitigate this risk, patients are often pre-medicated with antihistamines and sometimes corticosteroids before antivenom administration. Medical staff are always prepared with emergency medications, particularly epinephrine, to promptly treat anaphylaxis should it occur. A delayed allergic reaction known as serum sickness is another potential complication. This typically develops days to weeks after antivenom administration, as the patient's immune system mounts a delayed response to the foreign horse proteins. Symptoms of serum sickness can include fever, skin rashes, often itchy and widespread joint pain, swelling of lymph nodes, and sometimes kidney involvement. While uncomfortable serum sickness is generally not life-threatening and can be managed with anti-inflammatory medications and corticosteroids, the decision to administer antivenom therefore always involves a careful risk-benefit analysis, weighing the potential for allergic reactions against the severe, potentially fatal consequences of untreated stonefish envenomation. For severe stings, the benefits almost always outweigh the risks. The availability of stonefish antivenom is also a crucial factor. It is primarily produced by specialized facilities such as CSL Seqirus in Australia for species found in that region. Its distribution is focused on areas where stonefish envenomations are common, particularly in tropical and subtropical coastal regions of the Indo-Pacific. However, in more remote areas or certain developing nations, access to this vital countermeasure can be limited, underscoring the importance of preventative measures and robust first aid training. Antivenom also requires specific storage conditions, typically refrigeration to maintain its potency, which adds to the logistical challenges of its distribution. Even after successful antivenom administration and the resolution of systemic symptoms, the journey to full recovery is not always complete. The local tissue damage, the necrosis initiated by the venom, may continue to progress for a time, requiring meticulous wound care. This can involve debridement, the surgical removal of dead tissue to promote healing and prevent secondary infections. Pain management may still be necessary for residual discomfort, and in some cases, physical therapy may be required to regain full function of the affected limb. The psychological impact of such a traumatic event should also not be underestimated, and support for emotional recovery is often invaluable. The Stonefish Antivenom stands as a profound testament to the power of scientific inquiry and medical innovation. It transforms a potentially fatal encounter with nature's hidden dangers into a treatable condition, offering a pathway to healing and recovery. This understanding of the antivenom's embrace, its intricate science and life-saving application, now completes our exploration of the immediate medical responses. We turn our quiet contemplation now to the broader ecological role of the stonefish, its behavior diet, and its place within the vibrant, ancient tapestry of the reef. Behavior diet and ecological role. As the antivenoms embrace that testament to human ingenuity against nature's potent secrets gently recedes from the forefront of your contemplation, we now allow our awareness to drift back into the stonefish's own world. We seek to understand this creature not merely as a source of danger, but as a vital, intricate thread woven into the vast living fabric of the reef. We delve into the echoes of the deep, exploring its subtle behaviors, its chosen diet, and the often unseen yet profound ecological role it plays beneath the gentle, ceaseless rhythm of the waves. The primary behavior that defines the stonefish, that which forms the very cornerstone of its existence, is an almost absolute stillness. Imagine it, if you will, as a living meditation, a creature that has perfected the art of inertness. For hours, even for entire days, a stonefish can remain utterly motionless. Nestled within the intricate contours of the reef, its eyes unblinking, its body a part of the very substrate. This profound inactivity is not a sign of lethargy, but rather a highly evolved strategy, a behavioral camouflage that complements its physical disguise. It removes itself from the sensory radar of most marine life, which are instinctively wired to detect movement as a primary indicator of presence, be it predator or prey. By becoming a motionless rock, the stonefish effectively ceases to exist in the kinetic world of the reef. Yet this stillness is but the prelude to a moment of explosive, almost unbelievable speed. The stonefish is the quintessential ambush predator. Its hunting strategy is one of infinite patience followed by instantaneous, devastating action. As small fish crustaceans or other unsuspecting invertebrates swim or crawl within its strike zone, perceiving only a harmless algae-encrusted stone, the stonefish waits. Its small, upward-facing eyes, often obscured by fleshy growths, are nevertheless capable of detecting subtle movements in its immediate vicinity. Its lateral line system, a series of sensory pores running along its body, detects the faint pressure waves and vibrations in the water, signaling the proximity of potential prey. And then, in a blink, a mere fraction of a second, often less than 15 milliseconds, the stillness shatters. The stonefish executes what is known as a gape and suck feeding mechanism. Its large, upward-pointing mouth suddenly opens with astonishing rapidity, creating a powerful negative pressure, a vacuum effect in the water directly in front of it. This sudden pressure differential causes water, along with the unfortunate prey, to be forcefully sucked into its maw. It is an act of pure, unadulterated predatory efficiency, a silent explosion of consumption. The prey, caught completely unawares, is swallowed whole, and almost as quickly as the strike began. The stonefish resumes its stony vigil, becoming one with the reef floor. Once more, the only evidence of its hunt being a momentary ripple in the water swiftly absorbed by the gentle currents. While its stillness is paramount, the stonefish does move. When it does, its locomotion is typically slow and deliberate, a shuffling crawl across the seabed propelled by its broad pectoral fins. It might shift position to find a new, more advantageous ambush point, or to relocate to a more sheltered spot as the tides change. These movements are economical, conserving energy and always executed with a profound awareness of its surroundings, maintaining its camouflage even in transit. Scientists believe that while it can hunt at any time, it may be more active during crepuscular hours, dawn and dusk, or even at night when visibility is lower, and some of its prey species are more active. In terms of social structure, the stonefish is largely a solitary creature. It does not form schools or engage in complex social interactions. Each individual occupies its chosen patch of reef, a master of its own hidden domain. While there is no evidence of aggressive territorial defense in the conventional sense, its potent venom likely serves as an effective deterrent, ensuring that other bottom-dwelling fish generally give it a wide berth, recognizing the inherent danger its stillness represents. Reproduction in the stonefish remains one of the more elusive aspects of its life cycle, largely due to its camouflaged and solitary nature. Scientists theorize that, like many marine fish, stonefish engage in external fertilization. During spawning events which may be seasonal or influenced by lunar cycles, a female will release large quantities of eggs into the water column, which are then fertilized by sperm released by a male. The eggs are typically small and pelagic, meaning they float freely in the open ocean, drifting with the currents as part of the vast planktonic soup. This allows for wide dispersal of the offspring, reducing the competition and increasing the chances of finding new, suitable habitats. After a period of development, the eggs hatch into larval stonefish, tiny transparent creatures that spend their early lives drifting in the plankton, feeding on microscopic organisms. This larval stage is a period of extreme vulnerability, as they are prey for countless filter feeders and small fish. Those fortunate few that survive will eventually undergo metamorphosis, transforming into miniature versions of the adult stonefish. At this point, they settle down onto the seabed, instinctively seeking out the complex, textured environments that will allow them to begin their lifelong practice of camouflage and stillness, developing their venomous spines as they mature. The diet of the stonefish is primarily carnivorous, consisting of small fish, particularly those that are bottom-dwelling or slow-moving, such as gobies and blennies. It also preys heavily on crustaceans, including various species of shrimp and small crabs that scuttle across the reef floor. Occasionally, other invertebrates that venture too close, such as worms or mollusks, might also fall victim to its lightning-fast strike. This diet places the stonefish firmly within the food web as a mesopredator, an intermediate predator that helps regulate the populations of smaller organisms. Its ecological role, therefore, is multifaceted and crucial. As a predator, the stonefish exerts a subtle, yet significant influence on the populations of its prey species. By consuming smaller fish and crustaceans, it helps to maintain the delicate balance of the reef ecosystem, preventing any single prey species from overpopulating and potentially outcompeting others. This contributes to the overall biodiversity and health of the reef. Its specialized ambush hunting technique means it occupies a unique niche, reducing direct competition with more active pursuing predators. Conversely, the stonefish itself has very few natural predators. Its unparalleled camouflage makes it incredibly difficult for larger fish such as sharks or groupers to detect. And for those that might stumble upon it, the immediate agonizing pain delivered by its potent venom serves as a powerful, unforgettable deterrent. A single encounter is often enough to teach a predator a lasting lesson, ensuring that the stonefish is generally left undisturbed. However, very large, robust predators such as certain species of large reef sharks or rays might occasionally manage to consume a stonefish enduring the venomous defense, but such instances are believed to be rare. Juvenile stonefish being smaller and having less developed venom, apparatus may be more vulnerable to predation from certain marine birds when in extremely shallow waters, or from larger fish before their camouflage is fully perfected. The stonefish, in its silent rock-like existence, contributes to the overall resilience and complexity of the coral reef ecosystem. It is a testament to the power of extreme specialization, a creature that has honed a unique set of adaptations to thrive in a highly competitive environment. Its presence, though often unseen, is an integral part of the echoes of the deep. A subtle yet potent force shaping the behaviors and populations of the countless organisms that share its vibrant watery world. This deep understanding of its life within the reef now gently guides us to look backward, in time, to explore the ancient lineage and the evolutionary journey that forged this master of disguise and defense. The evolution of a master predator, as the intricate dance of the stonefish's life within the reef, its behaviors and its ecological contributions, gently settles into the quiet depths of your mind. We are now invited to cast our gaze further back beyond the immediate present, into the vast echoing corridors of geological time. We embark on a journey spanning millions of years, tracing the shadowy path of evolution that sculpted this master predator, transforming ancient fish into the camouflaged venomous sentinel we know today. The lineage of the stonefish, like a deep root system, extends far back into the evolutionary history of bony fishes. It belongs to a grand and diverse order known as the Scorpioniforms, a group commonly referred to as the male-cheeked fishes, due to a characteristic bony plate that extends from beneath the eye across the cheek. This ancient order, which includes the familiar scorpionfishes, lionfishes, and other spiny, often venomous bottom dwellers, represents a successful evolutionary radiation, with many members sharing a propensity for camouflage and defensive weaponry. The earliest known fossils attributed to this order date back to the Eocene epoch, perhaps 50 to 60 million years ago, suggesting a long and rich history of adaptation in marine environments. Within this broader family tree, the ancestors of the true stonefishes. Cynancea genus likely began their specialized journey in the complex dynamic environments of nascent coral reefs and rocky coastlines. Imagine a world where the continents were shifting, ocean currents were reorganizing, and marine life was constantly evolving in a relentless arms race of predation and defense. In such a competitive arena, any slight advantage in concealment or protection would have been heavily favored by the slow, unyielding hand of natural selection. The evolution of its unparalleled camouflage was almost certainly a gradual incremental process, a series of subtle refinements stretched across countless generations. Picture an ancestral fish, perhaps somewhat mottled in coloration, already possessing a tendency to rest on the seabed. Mutations, those random whispers in the genetic code, would have occasionally produced individuals with slightly more irregular skin textures, perhaps a few more bumps or ridges, or a coloration that blended marginally better with the surrounding rocks or corals. Those individuals, even with a fractional improvement in their ability to disappear, would have been marginally more successful at avoiding predators and crucially more effective at ambushing unsuspecting prey. They would have survived longer, reproduced more, and passed on their advantageous genes. Over millions of years, these tiny cumulative advantages would have progressively exaggerated, leading to the complex dermal papillae, the fleshy protuberances, and the remarkable chromatophore system we observe today. The stonefish became a living sculpture, its form and color meticulously carved by the relentless pressure to become invisible. Concurrently with the development of visual camouflage, the behavioral adaptation of profound stillness would have co-evolved. An animal that blends perfectly with its surroundings gains little advantage if it constantly moves. Thus, those ancestral fish that exhibited a greater propensity for immobility, for waiting patiently, would have further enhanced their camouflage effectiveness. This behavioral shift towards ambush predation would have been reinforced by the energy efficiency it offered. Rather than expending precious metabolic resources in chasing prey, the stonefish learned to let its meals come to it, a strategy perfectly suited to its increasingly perfected disguise. This synergy between physical form and behavior became a powerful engine for its evolutionary success. The development of its potent venom apparatus is another fascinating chapter in this ancient story. Many members of the Scorpaeniforms possess venomous spines, a common defensive trait across the order. The precursors to the stonefish's dorsal daggers were likely simple, sharp, bony spines, perhaps covered in irritating mucus, offering a basic deterrent against touch or attack. Over vast stretches of time, however, the evolutionary pathway for the stonefish diverged, driven by an intensified need for an uncompromising defense. Mutations that led to the development of specialized glandular tissue at the base of these spines, capable of producing more complex and potent toxins, would have been strongly selected for. Imagine the stages: first, perhaps a spine with a mild irritant, then a spine with a slightly more toxic mucus, then the gradual invagination of the skin to form rudimentary grooves, allowing for more efficient delivery of the increasingly potent chemical. Finally, the refinement into distinct venom glands nestled within those grooves, protected by a delicate sheath and designed for efficient, almost hypodermic injection upon pressure. The chemical composition of the venom itself would have undergone a parallel evolution, moving from simple irritants to the sophisticated cocktail of cytolysins, neurotoxins, and cardiotoxins that define stonus toxin and verrucotoxin today. Each molecular refinement, each increase in destructive power would have offered a greater chance of survival against larger, more aggressive marine predators. The beg for amputation level of pain, while horrific for humans, is from an evolutionary perspective an incredibly effective deterrent, ensuring that a predator learns a swift and unforgettable lesson. The geographical distribution of the stonefish, primarily across the vast Indo-Pacific, also tells a story of ancient migrations and geological forces. As continents drifted and sea levels fluctuated over millions of years, the shallow, warm waters of this region provided ideal conditions for the diversification and spread of reef-dwelling species. Larval stonefish carried by powerful ocean currents would have dispersed across immense distances, colonizing new reef systems and rocky shores. This wide dispersal, coupled with local adaptations to subtly different environments, may have contributed to the slight variations observed between different species of Synansia across their range. The enduring stability of tropical reef environments over geological timescales has also allowed for the long-term refinement of such specialized adaptations. In essence, the stonefish represents a pinnacle of convergent evolution in certain aspects. While its venom system is unique within its immediate lineage, the broader strategy of camouflage and ambush predation is a recurring motif in nature. Consider the flatfishes like flounders and sole, which also flatten their bodies and change color to blend seamlessly with sandy or muddy bottoms. Or certain frogfish, also masters of disguise and ambush in reef environments. These disparate creatures, through independent evolutionary paths, have arrived at similar solutions to the challenges of survival, underscoring the profound effectiveness of the stonefish's core strategy. The stonefish, therefore, is not a recent phenomenon. It is a living testament to millions of years of evolutionary pressure, a creature meticulously sculpted by the forces of natural selection to thrive in its specific, hidden niche. Every bump on its skin, every muted color, every potent drop of venom, and every moment of its profound stillness is an echo of ancient struggles of countless generations that survived by becoming invisible, by possessing an ultimate, uncompromising defense. It is a creature that whispers stories of deep time, reminding us that the most remarkable and dangerous forms of life often emerge from the slow, relentless grind of adaptation. As we allow this vast sweep of evolutionary history to settle within our minds, we gain a profound respect for the enduring power of nature's design. This understanding of its ancient lineage now gently guides us to explore its broader family, to glimpse the other venomous relatives that share its shadowy world, extending our contemplation beyond the stonefish itself. A family of venomous relatives. As the vast sweep of evolutionary history, that ancient journey of adaptation that forged the stonefish, gently settles within the quiet depths of your mind, we are now invited to broaden our gaze. We extend our contemplation beyond the solitary familiar rock to explore the wider family of venomous relatives that share its shadowy world, creatures that, while distinct, echo many of the stonefish's own formidable adaptations. The stonefish, in its profound stillness and potent defense, is not an isolated marvel, but rather a highly specialized member of a diverse and ancient order of ray-finned fishes known as the Scorpaeniforms. This grand lineage, often characterized by a distinctive bony plate extending across the cheek, earning them the moniker male-cheeked fishes, encompasses a remarkable array of species, many of which share the stonefish's predilection for bottom-dwelling habits, intricate camouflage, and crucially, venomous spines. Imagine this order as a sprawling family tree with numerous branches, each leading to a unique expression of similar core survival strategies. One of the most prominent branches, and perhaps the closest in spirit to the stonefish, is the Maor, scorpionfish, family Scorpaenidae. These are the stonefish's immediate cousins, and like them, they are masters of cryptic disguise. Picture a scorpionfish resting on a coral head or a rocky crevice. Its body, often broader and more flattened than that of a typical fish, is a mosaic of muted colors. Browns, reds, greens, and grays, all blended in intricate, disruptive patterns that break up its outline. Its skin is not smooth, but adorned with a profusion of fleshy flaps, tassels, and cirri small branched appendages that further mimic the surrounding algae hydroids or detritus. These dermal outgrowths are like living camouflage netting, blurring the edges of the fish's form and allowing it to melt into the visual clutter of its environment. Its large, often upward-pointing eyes are frequently overshadowed by bony ridges or fleshy adornments, further obscuring any telltale signs of life. Like the stonefish, scorpionfish are ambush predators relying on their masterful camouflage to remain undetected by both prey and potential predators. They exhibit a similar patient stillness, waiting for unsuspecting smaller fish and crustaceans to venture within striking distance before executing a rapid, vacuum-like strike. Their locomotion is typically a slow, deliberate crawl across the seabed, using their pectoral fins like delicate hands to maintain contact with the substrate, further emphasizing their inert appearance. The venom apparatus of the scorpionfish mirrors that of the stonefish in its fundamental design. They possess numerous sharp, bony spines, primarily along their dorsal fin, but also on their anal and pelvic fins. Each spine is grooved, and at its base, nestled within these grooves, lie the specialized venom glands. When pressure is applied to these spines, for instance, by an unwary diver's hand or a wader's foot, the integumentary sheath covering the spine is compressed and ruptures, allowing the venom to flow down the grooves and into the wound. The venom itself, while varying in specific composition between species, generally contains a complex mixture of proteins, including neurotoxins and cytotoxins designed to inflict pain and cause localized tissue damage. However, a key distinction often lies in the severity of the envenomation. While scorpionfish stings are intensely painful, often described as a burning, throbbing agony that can last for many hours, they are generally less potent and less likely to cause life-threatening systemic effects than a stonefish sting. The pain is typically localized, accompanied by significant swelling redness and sometimes blistering or localized tissue necrosis. Systemic symptoms like severe hypotension or cardiac distress are less common, but can occur especially in vulnerable individuals or with multiple stings. The first aid for scorpionfish stings is largely the same as for stonefish: immediate immersion in hot water to denature the thermolabile venom proteins, followed by medical evaluation. Moving further along the Scorpaeniformes family tree, we encounter the strikingly beautiful, yet equally venomous lionfish. These creatures, primarily belonging to the genus Pteroi, offer a fascinating contrast to the cryptic stonefish and scorpionfish. Instead of blending in, lionfish actively stand out, showcasing a bold, almost flamboyant display of their defensive weaponry. Imagine a creature adorned with long, flowing fan-like pectoral fins and tall, elegant dorsal spines, all dramatically striped with alternating bands of white, red, and black. This vivid coloration is not camouflage. It is a classic example of aposematism. A clear warning signal to potential predators. I am dangerous, do not touch. Lionfish are more active hunters than their stonefish cousins, often seen, hovering gracefully over the reef, their long, flowing fins creating a mesmerizing, almost hypnotic display. They herd smaller fish into corners or against the reef structure, using their expansive fins to block escape routes before delivering a swift, engulfing strike. Their venom apparatus is similar in principle to other scorpaenids, with sharp, grooved spines on their dorsal anal and pelvic fins, each housing venom glands. When threatened, the lionfish does not attempt to hide. Instead, it erects and spreads its formidable spines, presenting a bristling, impenetrable barrier. A sting from a lionfish, while excruciatingly painful, is generally considered less dangerous than a stonefish sting. The venom primarily causes intense local pain, swelling redness, and sometimes blistering or tissue discoloration. Systemic symptoms, though usually milder than those from a stonefish, can include nausea, vomiting, dizziness, headache, sweating, and weakness. Fatalities are exceedingly rare and usually associated with severe allergic reactions or underlying health conditions. Hot water immersion remains the primary first aid, effectively denaturing the venom and providing significant pain relief. The ecological impact of lionfish, particularly their invasive spread in the Atlantic and Caribbean, where they lack natural predators and compete with native species, is a significant concern for marine biologists. Beyond these more well-known relatives, the Scorpaeniformes order includes a host of other fascinating venomous fish. There are the Pseudosent waspfish family, Tetrarogidea. Small, often highly cryptic fish that resemble scorpionfish, but possess a deeper, more compressed body and fewer, more robust dorsal spines. They too are ambush predators of rocky and sandy bottoms, armed with venomous spines that can inflict painful stings, though generally less severe than those of stonefish. Their camouflage is often exquisite, allowing them to disappear among rubble and seaweed. Then there are the goblinfish family, Gnathanacanthidae. Peculiar-looking creatures with large, upward-pointing mouths and a unique, often mottled appearance, also possessing venomous spines. Even some species of flatheads platycephalidae, while not typically classified as highly venomous, can possess small, sharp spines on their gill covers, or fins that can cause painful, albeit usually mild, punctures. This widespread presence of venomous spines across such a diverse array of bottom-dwelling fish within the Scorpaeniformes order underscores the evolutionary success of this defensive strategy in marine environments. The shared evolutionary thread that binds these relatives, the stonefish, scorpionfish, lionfish, and others, is a common ancestry that developed and refined the use of venomous spines for defense. This adaptation likely arose as a response to intense predatory pressures in complex benthic habitats. By possessing a passive yet instantly active defense, these fish could survive without expending energy in flight or active confrontation, a strategy particularly advantageous for ambush predators that rely on stillness. However, within this shared lineage, the stonefish represents an extreme specialization. It pushed the boundaries of camouflage to an unparalleled degree, becoming almost indistinguishable from its environment. And crucially, it developed a venom of exceptional potency, a complex biochemical weapon designed not just to deter, but to inflict overwhelming pain and systemic damage. While its relatives possess effective venom, the stonefish's toxin stands out for its rapid onset, intense agony, and greater potential for life-threatening systemic effects. It is a testament to how evolution through relentless pressure can take a successful adaptation and refine it to its ultimate, most formidable expression. As we gently absorb the intricate diversity of this venomous family, allowing their varied forms and shared dangers to settle within the quiet pools of our understanding, we gain a deeper appreciation for the complex interplay of adaptation and survival in the ocean. This broadened perspective now guides us towards our final contemplation: the nuanced relationship between humans and these hidden, potent guardians of the reef, and the future reverence we must cultivate for their enigmatic existence. Human interaction and future reverence. As the intricate diversity of the stonefish's venomous family, their varied forms and shared dangers gently settles within the quiet pools of your understanding. We now allow our awareness to drift towards the delicate, often precarious intersection of their hidden world with our own. We explore the nuanced relationship between humans and these potent camouflaged guardians of the reef, contemplating the pathways to peaceful coexistence and the profound reverence we must cultivate for their enigmatic existence as we share the shallow, shimmering waters. The primary point of contact between humans and the stonefish is almost without exception entirely accidental. This creature, a living sculpture of stillness, does not actively pursue or attack. Its venom, as we have learned, is a purely defensive mechanism deployed only when direct pressure is applied to its formidable dorsal spines. The very perfection of its camouflage, its unparalleled ability to vanish into the visual clutter of the reef floor, is precisely what makes it such a significant yet unseen hazard to humans. Imagine a sun-drenched day, the warm, clear waters of a tropical reef, lapping gently at your ankles. The sand beneath your feet is soft, occasionally interspersed with fragments of coral or a scatter of weathered rocks. You wade slowly, perhaps admiring the small darting fish or the vibrant hues of a nearby coral colony, your mind absorbed in the tranquil beauty of the moment. It is in such serene, unsuspecting instances that the stonefish, perfectly blended, becomes an invisible threat, a silent sentry beneath your very step. The common scenarios for stonefish envenomation invariably involve human activity in their preferred shallow habitats. Picture a child playfully exploring a tide pool, reaching for what appears to be an interesting, oddly shaped rock, or a snorkeler drifting lazily over a coral garden, inadvertently letting a foot brush against the seabed. Consider a fisherman wading through the shallows tending nets or lines, or a beachcomber strolling along the low tide mark, where patches of reef or rocky outcrops are exposed or barely submerged. Even a diver focused on a distant marine spectacle might lean a hand onto what seems to be a stable, inert surface. In each of these moments, the stonefish in its profound stillness remains undetected until the moment of contact, triggering its ancient reflexive defense. The immediate searing pain that follows is not a sign of aggression, but a testament to its evolutionary success, a stark reminder of the hidden power that lies beneath the calm surface. Recognizing the stonefish's passive nature and its reliance on camouflage is the very first step towards preventing these painful encounters. Prevention, therefore, becomes a conscious act of awareness and respect for the environment we are entering. The most universally recommended and effective preventative measure is the wearing of thick-soled protective footwear. Whenever venturing into shallow marine environments where stonefish are known to reside, imagine slipping your feet into sturdy reef shoes or robust dive boots. The thick, rubberized sole acts as a crucial physical barrier, a protective shield between your delicate flesh and the stonefish's hardened, venomous spines. Even if an unwitting step lands directly upon a camouflaged fish, the spine is far less likely to penetrate the tough material of the sole, preventing the compression of the venom glands and the subsequent injection. This simple act of donning appropriate footwear transforms a potentially hazardous stroll into a significantly safer exploration. Beyond physical protection, a mindful approach to movement in the shallows is equally vital. The shuffle your feet technique, long advocated by experienced coastal dwellers and marine educators, offers an elegant solution. Instead of lifting your feet and stepping down with force, imagine gliding your feet gently along the seabed, almost as if you are shuffling through soft sand. This subtle, sweeping motion creates a series of gentle vibrations and disturbances in the water and sediment directly in front of your feet. A stonefish, in its motionless vigil, is exquisitely sensitive to these subtle shifts. The vibrations serve as an early warning signal, alerting the camouflaged fish to your approaching presence. Given its passive nature, its natural inclination will be to slowly, imperceptibly move away from the disturbance or to subtly shift its position rather than remaining in the direct path of an impending step. This technique allows for a respectful, non-confrontational warning, giving the stonefish an opportunity to avoid contact, thus protecting both itself and the wader. For snorkelers and divers, the mantra is clear and profound. Look, but do not touch. The allure of the reef with its vibrant colors and intricate textures can be incredibly strong, tempting hands to reach out and explore. However, the stonefish in its perfect mimicry can render itself indistinguishable from an algae-covered rock or a piece of dead coral. Cultivating a habit of observing marine life from a respectful distance, allowing your eyes to appreciate its beauty without the need for physical interaction, is a fundamental principle of safe and responsible marine exploration. This extends beyond stonefish to other venomous or fragile reef inhabitants, fostering an ethic of passive admiration that safeguards both human and marine life. Education, both for local communities and for tourists, plays an indispensable role in disseminating these preventative strategies. Clear signage in high-risk areas, informational brochures and local guides who impart knowledge about marine hazards are all crucial components of a comprehensive safety approach. From a cultural and historical perspective, coastal communities across the Indo-Pacific have long harbored a deep, often ancestral awareness of the stonefish. Generations of fishermen, pearl divers, and island dwellers have learned to navigate their environments with an innate understanding of its hidden presence. Tales of its potent sting are woven into local folklore, serving as cautionary warnings passed down through oral tradition. These historical interactions often led to the empirical discovery of basic first aid, such as the use of heat, long before modern science elucidated the thermolabile nature of the venom. This indigenous knowledge, born from intimate proximity to the ocean's dangers, underscores a profound inherent reverence for the power of nature, a respect earned through direct, often painful experience. This concept of reverence extends beyond mere avoidance. It encompasses a deeper appreciation for the stonefish's place within the intricate web of life. Despite its formidable defense, the stonefish is not a malicious creature. It is a marvel of evolution, a testament to the power of adaptation and an integral component of the reef ecosystem. As an ambush predator, it plays a vital role in regulating the populations of smaller fish and crustaceans, contributing to the overall health and balance of the coral reef. Its unique adaptations, from its unparalleled camouflage to its potent venom, represent millions of years of evolutionary refinement, a biological masterpiece forged by the relentless pressures of survival. The future of our interaction with the stonefish, and indeed with all of the ocean's wondrous and sometimes dangerous inhabitants, must be guided by this reverence. As human populations continue to expand and our activities increasingly encroach upon marine environments, the potential for encounters intensifies. Thus, our responsibility to understand, respect, and protect these ecosystems becomes paramount. Threats such as habitat destruction, pollution, and the pervasive impacts of climate change, which lead to coral bleaching and ocean acidification, indirectly threaten the stonefish by degrading the very reefs and rocky shores it calls home. Protecting these environments is not just about preserving biodiversity. It is about maintaining the delicate balance that allows creatures like the stonefish to thrive in their ancient, specialized niches. Our shared future in the shallows demands a commitment to mindful coexistence. It necessitates ongoing scientific research to further understand stonefish venom, to refine antivenom production, and to improve treatment protocols. It requires continuous public education, ensuring that both local residents and visitors are equipped with the knowledge and tools to prevent stings and respond effectively if they occur. It calls for a deeper philosophical shift, moving away from a perspective of conquest or fear towards one of respectful stewardship. The stonefish, in its quiet, unassuming power, serves as a poignant reminder that the ocean is a realm of profound beauty, intricate life, and inherent mystery. It is a world that continues to unfold its secrets, inviting us to explore with curiosity, to interact with caution, and to live alongside its wonders with an enduring sense of humility and profound reverence for the astonishing tapestry of life that graces our planet's blue heart. The gentle, ceaseless rhythm of the waves continues a timeless lullaby, accompanying the ongoing dance of life in the silent, shimmering shallows. And so, as we drift away from the silent, shimmering shallows and the camouflaged secrets they hold, consider the profound interconnectedness of all existence. The very minerals that form the stonefish's rugged skin, the intricate proteins of its potent venom, the water that cradles its hidden life. All are composed of atoms forged in the fiery hearts of distant ancient stars. And so are you. The calcium in your bones, the iron in your blood, the carbon that forms the very structure of your being whispers of cosmic dust and primordial oceans. Just as the stonefish finds its perfect stillness, its profound, unmoving peace amidst the ceaseless currents of the reef, may you now find your own deep calm. As the ocean's rhythms gently lull the world, allow your mind to settle into that same quietude, letting your thoughts drift like soft plankton on an unseen current. May the deep, silent currents of the ocean cradle your dreams, carrying you to a profound and regenerating rest. Sleep well, goodbye, and see you again.